Connecting rod length can create certain parameters in an Otto cycle engine that either would increase thermal or volumetric efficiency. We will get to an existing engine design that can benefit from both traits but not quite in Otto cycle form. In this channel, there is also a piece on secondary vibrations that may lend itself here to make it easier to understand the effects of connecting rod's maximum angle. The Otto cycle engine basically consists of a crankshaft, connecting rod and piston. Interestingly, the crankshaft motion runs a perfect rotation, while the piston is in a perfectly straight line. The former is perfectly constant while the latter is perfectly reciprocating. The connecting rod, however, finds itself between these conflicting motions as it connects the two ends. Being an intermediate, it finds itself in an awkward imperfection between the two. This imperfection lends itself being able to tune and change the imperfect motion of how fast the piston move upwards and downwards as the maximum angle of a connecting rod changes with different rod length. The longer the rod, the less maximum angle, and even more so with an offset dicussed Z setup. On the dicussed Z, this is exclusively for the combustion and intake stroke. The longer the rod, the less inherent imperfection there is to an Otto cycle engine. The maximum angle of a connecting rod is at the midpoint of a crank stroke. This gets complicated with an offset cylinder dicussed Z setup as it splits the piston's acceleration and deceleration differences into four sets. It has the 90 degrees downstroke section with reduced connecting rod maximum angle, while on the upstroke, at 270 degrees, it has more maximum angle, plus the added degree angle midpoint tilt created by the off-center cylinder to crankshaft. So the advantage of using longer connecting rod is how it improves thermal efficiency. A long rod's reduced maximum angle also means that the piston is positioned higher up the cylinder to the crank's midpoint angle compared to a shorter connecting rod. This also means from top dead center, at 0 degrees towards that 90 degrees crank angle, the piston is moving slower than on a shorter connecting rod. This is known as longer dwell time. This improves thermal efficiency by having better pressure retention during combustion. To make it easy to understand, say there are two engines and both have a compression ratio of 10:1. One engine runs on a shorter length connecting rod, and the other on a longer connecting rod. That 10:1 maximum compression ratio is at top dead center, or at the crankshaft's 0 degrees angle. Now what about when the crank has turned at, say, a 10 degrees angle? This is where the difference is. At this point, the long rod engine will achieve a higher compression ratio compared to a shorter length connecting rod engine, and this continues past the crank rotation's midpoint. This goes back to the fact that the piston is traveling at a slower motion towards the crankshaft's midpoint. So the loss in compression ratio by the long rod engine as the piston goes downwards is less compared to an engine with shorter connecting rod. On volumetric efficiency, a shorter connecting rod actually benefits more here. The faster dwell time of the piston means it opens up the cylinder's displacement at a higher rate, increasing the space to bring in more air into the cylinder for the same given crank angle and time. This faster piston dwell time, however, is not favorable with combustion pressure retention, hence the trend in engine manufacturers to eventually select a longer rod ratio as their preferred choice. Thermal efficiency over volumetric efficiency. Since an engine works for combustion, gains in this cycle becomes most substantial. The difference in velocity that the piston reaches top dead center has the long connecting rod at an advantage, as it won't be subjected to as much g-forces than a shorter connecting rod. Its additional mass, however, may be subject the crankshaft to more forces. The same cannot be said of the dicussed setup. The final quarter movement of the piston is its highest rate towards top dead center. The reduction in connecting rod maximum angle also reduces side forces, or thrust load by the piston subjected to the cylinder liner, and this is especially important during high-stress combustion stroke, where an offset cylinder engine reduces this even further. The reduced thrust load forces on the cylinder liner by the piston also means it reduces friction. This reduction in maximum angle of a longer connecting rod also helps to reduce inherent secondary vibrations, and there is a video on this channel that explains this. The thing about long rod is that as the rod is specified to be longer and longer, the difference in minimizing its maximum angle point is less substantial for the given weight penalty of having a longer cylinder bore or block. Connecting rod, cam drive, connecting rod weight that affect the crankshaft strength, meaning weight. Simply put, past a certain point, the greater the rod length, the less difference it makes.